check for 3.5 exercises 25 through 38. This section has to do with equation solving and modeling. And specifically, we're talking about logarithmic and exponential equations. In this exercise set 25 through 38, solve each equation by the method of your choice. Support your solution by a second method. So for this, I'm going to solve, if it looks to me like the equation can be solved algebraically, I will do it that way, and if not, I will solve by graphing or some other method. And it really comes down to kind of the experience of knowing which equations are going to be easier to solve by graphing or not. In this case, problem 25, log, which means log base 10 of x squared is equal to 6. And so we're going to rewrite this equation as an exponential equation. And so the base of the logarithm, which is 10, becomes the base of the exponent. So 10 to the power of 6 is equal to x squared. And in order to solve this, we're going to isolate x. And to do that, we're going to take the square root of both sides of this equation. So we take the square root of 10 to the 6th power on the left side and the square root of x squared on the right side. Well, square root of x squared is going to be x. And the square root of 10 to the 6th power, that's going to be the same. The square root of 10 to the 6th power is going to be the same thing as 10 to the 6th raised to the power of 1/2. Well, what's 1/2 times 6? Well, that's going to be 3. So we're going to have 10 to the 3rd power. And since we're taking the square root, we're going to have plus or minus. So we can rewrite this answer as x equals plus or minus 1,000, which is 10 to the 3rd power. Next it says support or solution by a second method. So we'll use a check method. Now I think I'm going to use the negative 1,000. We can check the positive, so I'm going to press Control I and get an add calculator. And for that, I'm going to try negative 1,000, negative 1,000. In storage, I'm going to press Control, bars, and I'm going to use A. So there we have negative 1,000 stored. So we're going to use the expression, which is going to be log, and that's going to be base 10 of a squared, right? So I'm going to put a, and a we stored as negative 1,000, and we should get 6, which we do. And if we did the same thing with 1,000 for a, we would get the same thing. So we're going to box in our answer here is correct. X equals plus or minus 1,000. Next on our problem 27, we have the common logarithm of x to the 4th equals 2. So quite similar to problem 25. That's going to be log base 10 of x to the 4th power is equal to 2. And rewriting this logarithmic equation, this exponential equation, we have 10 to the power of 2 equals x to the 4th power. So we could take the 4th root. I'm going to do this one at a time. I'm just going to take the square root of each side. So we're going to have the square root of x to the 4th power is going to be x squared. It's going to be equal to the square root of 10 squared, which is just going to be the square root and squared cancel each other. So we're going to get plus or minus 10. But really, to solve again, we're going to have to take the square root. To take the square root of this right side, we can't take the square root of the negative number. So I'm going to have to erase this negative out of here. And we end up taking the square root of positive 10. So x is going to be equal to plus or minus the square root of 10. And we could have also, right from the get-go here, we could have taken this 10 squared equals x to the fourth. We could have taken the fourth root, right? And if we take the fourth root, we would have x is equal to plus or minus, and the fourth root of 2 is going to be 10 to the 1/2 power, which equals plus or minus square root of 10. And then to test, we'll go to our calculator again and put, this time we'll test the positive value. So we'll put square root of 10, and that's going to be storage, control vars A. So we get this 3.16. Go back to our original equation, which is going to be log, and that's going to be base 10 of, that's going to be a to the fourth, and we should get 2, which we did. So this confirms that x equals plus or minus square root of 10 is the correct answer. We would have got the same thing by squaring this negative square root of 10 to the fourth power would have given us the same thing. That's a check. Next problem, 29. We have 2 to the power of x minus 2 to the power of negative x over 3 equals 4. For this one, we're going to solve this one by graphing. So solve by graphing. Essentially, when you solve by graphing, what you're doing, at least the way I like to do it, there are different ways to solve by graphing. If you set one of the sides of the equation equal to 0, so if I subtract 4 from each side of this equation, on the right side we have 0, on the left side we have 2 to the power of x minus 2 to the power of negative x over 3 minus 4 is equal to 0. So now to graph, all we have to do is take the function f of x equals 2 to the power of x minus 2 to the power of negative x over 3 minus 4. When we graph that, we see where the function value, the graph function crosses or touches the x-axis. That'll be our real solution, or real solutions. So now I'm going to go to Control I and add graph. And it so happens that this function I placed earlier in the calculator, so we have 2 to the power of x minus 2 to the power of negative x over 3 minus 4. And we press that, and we see a solution between x equals 3 and x equals 4. And to find out what precisely that is, if we go to our menu, we go to Analyze Graph, and then option 1 here is 0. It says lower bound here at the lower left of the view screen. We go to the left of our x-intercept, press enter. Now it says upper bound, we press enter, and we get this value here, 3.59. Well, 3.59 is going to be a decimalized approximation to 2 decimal places. And what we want to do is see if we can get a more exact number than 2 decimal places. And to do this with our T-Inspire calculator, if you can arrange that you have your open hand, okay, which we have here, see that open hand over that 3.59, then we can take the plus sign here. Okay, if you hit the plus key on the calculator, which I'm doing now, you're opening up to more decimal places. So what we've done now is we have, instead of 3.59, we have 3.5948784. So I'm going to come and write this down. X equals 3.5948784. And we'll see how that works out. And to do that, 3.5948784, that's right. So I'm going to go to another calculator page, Control I, add calculator, and I'm going to put 3.5948784, and then I'm going to store that again, Control vars A. Okay, and now we're going to enter this value into our original equation. And to do that, that's going to be 2 to the power of A. So 2 to the power of A minus 2 to the power of negative A power of negative A, here we go. And we take this all over 3, we should get 4. And we get 4, and we get exactly 4 according to this calculation. So that's a check. So we know that this answer, in fact, the calculator thinks it's exactly 4. I put the approximately equal to squiggle. There we have, that's problem number 29. Next on our problem, which is 31. Again, we have e to the x plus e to the negative x over 2 equals 4. So over 2 is equal to 4. And we're going to solve this equation for 0 both by subtracting 4 from both sides. So we get 0 equals e to the x plus e to the negative x over 2 minus 4. And so we're going to just make this as f of x to make this graphable. A graphable solved by graphing function using the x-intercept method plus e to the negative x over 2 minus 4. So we go to our graphing calculator again, and I'm going to go to Control I and add graph. I'm going to go to this function f2 that I've already entered and press enter. Now this looks like a quadratic function. In fact, since it looks like a quadratic function, I have my suspicions that this thing might be solvable somehow algebraically, but this is solved graphically. So what I'm going to do is analyze to find the solution. I'm going to press menu, analyze graph, and 0. And we have this lower bound, we go to the left, and the upper bound, we go here. And again, we have that 0. I'm going to go again and try to find a more, we have 2.06. We push the open hand over to 2.06 and press the plus sign. So we have 2.06 3437. Okay, 2.06 3437. Before that, I'm going to check the left one too. Just see what it is. Analyze graph and 0. Okay, left, right. Okay, again we have 2.06. I'm going to make an assumption that's going to be the same thing. Well, why not just check it out? Put the open hand over the thing. Press the plus sign. Yeah, see, it's the same thing but negative. 2.063437. In this case, 371. .06 2.06 34371, we will say. That's to the 10 millionth place. Okay. We're going to go and check this solution by another method. Control I and add calculator. 2.0634371 and control bars A. And we're going to enter the original function we had, which is e to the A, and that's going to be plus e to the negative A power, and that all over 2 should equal 4, which it does. So this would be our correct answer. Okay, next odd number problem, which is 33, we have 500 over 1 plus 25e to the 0.3x equals 200. So I'm going to rewrite this equation here. 500 equals, or excuse me, 500 over 1 plus 25e to the 0.3x. Instead of putting 0.3, I just put 0.3. Okay, and that's going to be equal to 200. Now to solve this, I'm going to try to solve this algebraically. To do that, I'm going to multiply both sides of this equation by the quantity 1 plus 25e to the power of 0.3x. And we do that, and we multiply this quantity 1 plus 25e to the 0.3x power. They're going to cancel. So we're going to have 500 is equal to 200 times quantity 1 plus 25 e to the 0.3x power. And now we can divide by 200 both sides of the equation. And we have 200 over 200 on the right side cancel equal 1. So in the left we have 500 over 200 equals 5 halves. So we have 1 plus 25 e to the power of 0.3x is equal to 5 halves. Next we're going to get rid of this 1 on the left side, and we're to do that, we're going to subtract 1, which is negative 2 over 2. So subtracting negative 2 over 2 from both sides, 1 minus 2 over 2 cancels equal 1. And what we have left is 25e to the 0.3x equals 5 halves minus 2 halves, which is 3 halves. And next we're going to take this equation up here to the upper right, and we're going to take, I'm just going to rewrite this, 25 e to the 0.3x equals 3 halves. And we're going to divide each side of the equation by 25. And dividing by 25 is the same as multiplying by reciprocal, so that's going to be 3 over 2 times 1 over 25. So we're going to end up with e to the power of 0.3x is equal to 3 over 50. Okay, we're getting closer now. The next thing we're going to do is take the natural logarithm of each side of this equation. So we have natural logarithm of e to the 0.3x equals the natural logarithm of 3 over 50. Next, the ln and the e cancel each other, so we get 0.3x is equal to the natural logarithm of 3/50ths. And last step to solve for x, we divide by 0.3. We have x is equal to the natural logarithm of 3/50 over 0.3. Let's go to our calculator. X equals, let's go get this thing. Let's go. Yeah, I'll go like this. So we have e, or the natural logarithm of 3/50, right? So natural logarithm of 3/50 and divide that by 0.3, we get negative 9.3837. And we can test that value in our original function. So go back to our calculator, and in our calculator we press Control Vars A. Now what that does, it automatically puts in our last number calculated, which is this. So we're going to put, just remembering our equation here, original equation, 500 over, okay, so we get our division, 500 over 1 plus 25 e to the power of 0.3, and that's going to be a. And we press this in, we should get 200 if we're right, and we do, so that checks out. And so we checked by another method, and we know this is our correct answer. X equals negative 9.37804. Next odd number problem, 35, we have 1/2 the natural logarithm of x plus 3 minus the natural logarithm of x equals 0. Initially, this thing didn't look like it was tremendously solvable. Well, I tried to solve it algebraically one way. It didn't work out so well, but I finally came around to getting this. So we have 1/2 the natural logarithm of quantity x plus 3. And what I'm going to do is add ln x, or logarithm of x, to both sides of this equation. So this is going to be equal to the natural logarithm of x. And next, the property of logarithm, we're going to take this 1/2 and make this the exponent of this quantity x plus 3. So we're going to have the natural logarithm of, and to the 1/2 power, that's going to be the square root. So we have x plus 3 square root. So that's going to be that one. On the right side, we're just going to have natural logarithm of x. Now next, we're going to get rid of our natural logarithm on both sides by taking e to the power of ln. So I'm putting this e just to the lower left of this ln. So e to the power of ln. Well, the e to the powers of are going to cancel each other out on each side of the equation. So what we're left with is the square root of this quantity x plus 3, and that's going to be equal to x. And our next step is to solve this equation. We're going to square both sides of this equation. So I'm going to take this quantity, the square root of x plus 3 squared equals x squared. And so when we square everything out, we're going to have x plus 3 equals x squared. And next, we're going to solve this equation for 0 on the left side. If we subtract x and subtract 3 from each side of the equation, subtract x, subtract 3, we're going to end up with 0 equals x squared minus x minus 3. And we would try to factor this equation, and I have tried to factor it. It wouldn't work out factoring. So we're going to use the quadratic formula, which is x equals negative b, a negative boy, went to a radical party at b squared. Because he thought he was square, he missed out on 4 awesome chicks, and the party was over by 2 a.m. And so we have these, we can fill in the parentheses. We have negative, we leave b like this, plus or minus. Inside the radical here, we leave a parentheses for b squared, minus 4, open parentheses for the a and c, over 2 open parentheses. And so in this standard form, we have a is equal to 1, 1x squared, b is equal to negative 1, and c is equal to negative 3. And then we just plug these values in the holes, and so we have where b is, we put negative 1 there, and negative 1 here inside the radical, and for a, well, a is 1, and c is negative 3, and 2 again for a in the bottom here, 2 times 1. And having parentheses like this really eliminates opportunities for errors, because if you don't have parentheses, it's easier to make mistakes. So what we have here is x equals, we have negative 1, so we have 1 plus or minus, and inside here we have negative 1 squared, which is 1, and minus 4 times 1 times negative 3. So a negative times a negative is positive, so we're going to have the square root of 13. And we're going to have that over 2. And so in our calculator, we would say, I'll just put this down, x equals 1 plus square root of 13 over 2. So let's do that. They control 1 plus square root of 13 over 2. And we get 2.30278. And this is going to be plus or minus. So we can also take the minus portion here. Let's go back to our calculator. So we're going to have 1 minus square root of 13 over 2. And we get this negative 1.30278. Well, here's what happens. We take this negative 1.30, but if you take the natural logarithm of a negative number, that does not compute, because in the domain of a logarithmic function, you have greater than 0 to infinity. So negative 1.3 isn't going to work. So this is going to be our answer, provided that it checks out properly. And to do that, I'm going to store that for a, plug that back into the original equation, see if we approximate 0. And to do that, we go back to calculator, and I'm going to put control vars a. Oops, but what happens? That's going to put the wrong number here. So I'm going to put 2.30278, and then control vars a. Okay, so that's going to be what we have, and we put that back into our original equation, which is going to be 1/2 and we have the natural log rhythm of the square root of, that's not the square root of, shouldn't be that. the natural logarithm of, we're going to have x plus 3, is it? And we're going to have minus, but remember, we stored in a, so I'm going to go ahead and back here put a. And then we're going to have minus ln, natural logarithm of a. And we should get 0 if we're correct here. And yeah, we get negative 0.000001, so we'll get negative 1/millionth, so that's very close to 0. So that's really a demonstration that our answer here is correct. Okay, last odd number problem we have, which is 37. We have the natural logarithm of x minus 3 plus the natural logarithm of x plus 4 equals 3 natural logarithm of 2. And so we can rewrite and kind of combine logarithms. I'm going to do this below. We have the natural logarithm of two separate natural logarithms we can write as the natural logarithm of a factor of these two products. So we can rewrite this as the natural logarithm of quantity x minus 3 times quantity x plus 4. And then on the right side, we can take this 3 and bring this 3 over here and make this the natural logarithm of 2 to the power of 3 equals the natural logarithm of 8. Okay? Next, we can exponentiate each side by the power of e. So e to the ln that, e to that. And so the e's and ln's cancel out on each side of this equation. And so what we have left is this quantity x plus minus 3 times quantity x plus 4 is equal to 8. And multiplying through, we're going to have x squared, and we have negative 3x plus 4x, that's going to be plus x, and then negative 3 times 4 is going to be minus 12, is equal to 8. And subtracting 8 from each side of the equation, we're going to have x squared plus x minus 20 is equal to 0. And we can factor out this x squared plus x minus 20 to be equal to x, and x are the factors of x squared, and we're going to have minus plus 4, right? 4, so I think it's going to be plus 5 and minus 4. So coming up to the right, we have x plus 5 is equal to 0, and x minus 4 equal to 0, and we know that because of the zero factor property. Anything times 0 is 0. So we have x equals negative 5 and x equals 4. And if we go back to our original equation and plug in negative 5, well, the first thing we're going to have is the natural logarithm of negative 5 minus 3. We're going to have the natural logarithm of negative 8. And on this other one, we would have negative 5 plus 4. We're going to have the natural logarithm of negative 1. So that's just not going to work. So what we call this one here, x equals negative 5, we call this an extraneous solution. Because it was a solution that was really created in the process of solving the problem. So 4 is going to be what our answer is. So we're going to plug in 4, see if we get a correct answer. So I'm going to put 4 storage A. So we have A stored. So what we have is I'm going to try to remember here, the natural logarithm of quantity A minus 3, natural logarithm of A plus 4, okay? So natural logarithm of a plus 3 plus let's see, make sure that's right. We have a minus 3 and a plus 4. Let's go back here. Yeah, a minus 3, let's go back here. A minus 3 plus natural logarithm of a plus 4. Okay, so we're going to get a value here, and then that should be the same as 3 times the natural logarithm of 2. I hope they're the same, and they are. Check, check. So we've checked, and we know that this is a real solution, x equals 4. So I'll say real solution. We had one real solution and one extraneous solution. And the real solution we were able to check. So anyway, those are the odd numbered problems solved with a variety of methods. There was the numerical solve feature on the T-Inspire calculator we did not use. But good luck on your even number problems as a demonstration of your learning, and thanks for viewing.